Today we're going to go over an SQL tip. It's just something that's kind of come up uh, quite a few times over the last couple of months, and I thought I would share it with you all. And so I'm calling it translating ors to unions. So the technique here is you've got a query and it's using a compound where clause that contains ors in it, and I've seen that most of the SQL optimizers for a lot of the popular databases don't really deal with this too well, and they're not able to effectively use indexes that may exist on the columns that are included in that where clause. And so what I've been trying to do is translate these compound or where clauses into unions, because I've had a lot more luck with the optimizers selecting much more efficient execution plans when their indexes are available on those columns. So here's really all it looks like. You've got a SQL statement. So we're selecting from a table and we're saying where a column equals a value, or another column equals a value, or maybe another column equals a value. And so the translation of that just winds up being splitting off these individual sections of the where clause and putting them into their own query, independent query, and then unioning the results. And so, what a union is going to do is run these three different statements, and it's going to combine all of the result sets. And when you say union, it's not only just going to combine them, it's also going to deduplicate them. If you happen to have the same row come back from each or from multiple sections of this query, it will actually deduplicate them if you have union. If you have union all, which is a special construct of the union, it will not deduplicate them. Now, one thing you need to be aware of is when it goes and deduplicates them, it does take another pass over that result set. And so that will have an impact on your performance. So next we're going to jump into a little demo here where I'm going to show you guys the actual IO stats when you perform this conversion. I'm going to jump over to SSMS here. So I've got a table named person that we're going to query. And so the original SQL statement looks like this. So I've got a where clause that's looking for first name equals Raphael, or the case where middle name equals C and the last name is Price. So I've got a compound where clause separated by an or. This is what we're trying to optimize. And just so you know, we've got indexes on all these columns that are in the where clause. So we've got an index on last name, middle name, and first name. But when we run this statement, and what I've done here is I've turned set statistics IO on, and that's what enables this output that you're seeing down here. So we've got statistics IO on. We're going to run our statement that's got the or, and we're going to go to the messages tab. That's where this information gets displayed. And so we've got logical reads against the person table sitting at 444. So now we're going to go to the translated SQL statement. And as you can see here, I've got one SQL statement that just has the first name equals Raphael in the where clause, which matches this. And I've got the other SQL statement as part of the union that just has this part of the where clause. And when you combine these in a union, these are equivalent. And there's a little twist here. There's a reason why there's a distinct here. I'm going to explain that in a minute. But now we're going to run the union version of the query. And we go to the messages tab. And I've copied this output here up here so you can see a little bit better. This is the text here is a little bit bigger. But the one thing to note is that the logical reads here is 44 as opposed to 444, which is 10 times the amount. So basically what we have reduced the cost of this query significantly just by splitting off the where clauses and creating a union between the two. Now, the one thing I wanted to touch on, and the reason why there's a distinct here, is because when you do a union will actually make an extra pass through the result set and remove duplicates. So as you can see, we've only got 3 rows in the result set. But I'm just going to run one section of the query. And as you can see, there's actually 15 rows that get called that come back from that. That's because there are multiple rows with the same value here. And that union is actually deduplicifying the rows. And that's why I had to put the distinct there so everything looked the same. If I run this without the distinct, we're going to also see that we've got the 15 rows. So just a little twist there that you need to be aware of when you're using union. For today, I do appreciate you guys watching the video. If you did enjoy it, please like, consider subscribing to the channel, and of course, put your comments and questions below. Talk to you guys later.